Well, good morning, everybody, and welcome to Ellensburg, Washington, USA, home of trees, roses, blue skies, puffy clouds, and warm temperatures. Thank you, as always, for those of you typing in 5x5. That means we're loud and clear, and I really do appreciate that. Thank you. Let's have you continue to enjoy for just a moment the view out to the south window. I'd like to establish where you are. And you are looking live, so if you're watching this in replay, 12 minutes from now we will begin today's lesson. But right now, we are communicating live on YouTube. I'm holding a dorky red iPad. There are students behind me. There are thank yous today. And as always, we'll just establish what's going on in the classroom here. There's plenty of chatter, plenty of life, which is good news, always welcome news, to hear the buzz going on, whether it's about geology or not. Where are you viewing from on this beautiful June 3rd of 2025? Half Moon Bay, California. Hello, Ray. Ben is in the Netherlands, Burlington, Washington. Raquel and Faith are doing the old switcheroo. Stefano is from Italy. Hello, Stefano. Craig is in the Metau. Torrance, California. That's Frank. Oscar from San Diego, California has shipped a bonus box of high-quality Korean chalk, luminous color. And so we are set. We are in good shape thanks to your generosity, Oscar. Thank you. Tucson, Arizona, Tinley Park, Illinois, Orlando, Florida, Dallas, Texas. Yeah, we got some new handouts, everybody. Los Angeles, California. I've got another big gift coming in just a second, but I need to say hi to a few more folks. Les is in England. Pittsburgh, Pennsylvania. I do have the plaque in my office. Yes, thank you. Northwoods, Wisconsin. That's Gene. Glenoma, Washington. Where's Glenona? Glenoma. 8-ball, Brian. Pat Miller. I'm sorry, Pat. I didn't recognize you. If I came over and had you talk into the mic, sorry. Didn't realize that was you. Thank you for coming on Sunday. Jim's in stormy Lake Koshkonong, Wisconsin. Saber is in Wisconsin Dells at Culver's. Oh, those burgers in the pouring rain. Saber, very nice. My dad loved those shakes. The flavor of the month or whatever. Flavor of the week? I don't know. He, on the way to the farm, he'd always... Anyway. I'm Just Stardust says hello from Canada. Martina says hello from Croatia. Hello, Martina. Yakima Lance in the hizzy. Hello, Yakima Lance. Nice to have you here. And so on. So thank you. A couple more quick thank yous. Ann from West Allis, Wisconsin. I emailed you and thanked you, but I also want to thank you here publicly. Ann saw one of my photographs on this 351 field trip a month and a half ago, I guess. We were in Moses Coulee. I was sitting in a little side canyon with Julie and Indigo and a few others. Julie was inspired by that basalt scene. And so Julie from Wisconsin painted this and sent this. Talus, Moses Coulee, Washington. So thank you, Ann from West Allis, Wisconsin. And finally, Janet and her husband. That's all the information I have. Janet, if you're watching in the live chat, can you type in where you're from and maybe the name of your husband as well? But Janet, I think, called Vindman's, but maybe dropped into Vindman's and said, would you please buy some downtowners, or would you please Janet and her husband said, we'll give you a little money, Jeff, at Vindman's, and would you please make some downtowners for the class and cut them into quarters or halves or something. So we have lots of beautiful, fresh downtowners. Pastries from Vinman's Bakery. You've got to love it, and thank you, Janet and husband. All right. We got free Danishes. Come on over, everybody. Come on over. Free downtowners, please help yourself. This is courtesy of Janet and her husband. Janet and her husband, everybody. It pays to be in this class. Thanks, everybody. Hope you enjoyed today's lecture. We will start in 6 minutes or something like that. Thanks. We need something. I don't know. Do we need something?
Not really. It feels pretty good in here.
Okay, good. That's enough.
We're just quiet because it's final.
Okay. All right. Let's not overthink it. We have.
How can you not overthink geochemistry? Yeah, we're very
How can you not overthink geochemistry? How do you not overthink it?
Yeah, how do you not?
In other words, how do you think it? It's like a.
How do you
not
think
over?
it, but not overthink it?
How do you think it but not overthink it? I don't know. I never learned that stuff to begin with.
If you were in geochemistry, would you be panicking with an exam tomorrow? Oh, dang it.
No.
Okay, I'm not panicked, but
You're concerned. It'll be fine. Ryan says it'll be fine. Ryan's just fresh off the beach. Free Danishes, handouts, free handouts, free Danishes. Two new ones, one retread. How was the trip, Ryan?
It was good.
it was fun.
It was fun and good.
Oh, you were there too.
No, I just heard it's fun.
It wasn't a fully enthusiastic. It was kind of, it was fun.
There was a plague van. There was a
It was,
sick van.
yeah, I was a part of the Blake band.
Are you sick now?
No, I recovered. Though I sprained my ankle on the last day, so that was awesome. Or bruised it something. I fell back in the band.
That'll happen.
Holding it together physically.
Jess with more detail than Ryan himself. Interesting. How does she know? She wasn't even at the coast. She knows so much. Listen, people are talking you would not believe.
You can't have one.
Why not?
Just said so. It's the parents' most famous line, because I said so.
Are you curious?
I assume that there are rocks that you pulled out of, or someone pulled out of the outcrops we're going to talk about.
From the archives. From the archives. You gonna go?
Annotated pictures.
Well, I'll try this. This will be fun. Let me sit off camera and talk to you since you can hear me. Are we still 5 by 5, everybody? Les has the munchies. Les is in Great Britain, I do believe. Tom wants to know how the pastry is. Oh, they hate it. Why did they say that? Jess, why did you say Vindman's Bakery makes terrible stuff? Why did you say that? That's
Horrible. It's like live.
it's live. Yeah, Vindman's Bakery is watching. Vindman's Bakery is not even close to Heyday Bakery. That's what everybody's saying in this room. Just kidding, just kidding. We love Vindman's Bakery, although Nick from South Africa still doesn't know where it is. 5 by 5, thank you.
They hear you loud and clear.
Yes, they do. Talking about Etna. Scrolling back, looking for inspiration. Hello, Regine, you're from France. Regine is from Cerbère. Martina, we are choosing not to think nor talk about what you're asking about, pretending it doesn't exist. Bernadette Yummers from Navarrete, Spain. Oh, Austin, come on now. Come on. This is you. This is you. You got your study buddy here. I can't get in the way of that. Is Janet? It's noon. We got half the class. It's frickin' noon. Seen? It's noon. High noon. Well, shockingly, it is noon. It is high noon. So, let us begin. Everybody, I welcome you today. People are dropping like flies. They're stressed out. They're using packing tape in the front row for some reason. We're sending packages across the ocean. You are here. There are brand new handouts. Grab them right now if you have not yet. There are free pastries from Vindman's Bakery, courtesy of Jennifer and her husband. Please help yourself to those as well. Come back for more. Come back for seconds or thirds. There's plenty here. So as we get settled, let me say a couple of quick announcements, and the people who are not here will be asking a new round of that, but they'll have to figure that out on their own. Weird energy right off the bat. I appreciate you being here. There we go. I appreciate you being here. I canceled the vans for Thursday. We're going to carpool. We're going to go out to Thorpe on Highway 10, snoozer. We've all been there a million times. Well, what I've got today and on Thursday is a bunch of new stuff for me, and therefore I think for you as well. So we'll see one of those outcrops right along Highway 10 at Thorpe with a new set of eyes. Then we're going to go to a place that almost no one has been to, Beatus Road, which is not far from that exposure. So in other words, there's 2 field trip spots on Thursday afternoon, less than 15 minutes away from here. So I canceled the van, so we'll just carpool and we'll make it happen. When we're done with those 2 stops, I invite you to my backyard and my oak tree. And we'll sit under my oak tree and I'll have yellow pens for everybody. We'll have picnic blankets and I have wine. I have a lot of wine that I want to get rid of and I want to share it with you. And you're like, but I'm not 21. It's okay. It's time to grow up. We're going to have some wine together, okay? So there's my street address. I'm not announcing it publicly, but there it is. If Chris figures out we're doing this, somebody's going to have to help Chris and figure out how to get to the address. But we'll get there, okay? So that's Thursday afternoon when we're done with our 2 stops at Thorpe, and we'll just celebrate the end of the quarter. Okay? So I know I said vans in the email, but that's not true. You know our final exam is a week from today. It's been in those emails the whole last 6 weeks. So I don't need to say much more about that, except it'll be the same exact format as the first time around. 5 questions, 5 pages, covering only the second half of the quarter. Okay, weird, awkward energy, let's go. People are rolling in, they're finding their way. Chris found his way to the classroom. Good. I start with a bold open. And here it is. 10 years ago, I came up with a pet name that I still like. Ghost volcano. A ghost volcano. And I didn't find it anyplace, I invented it essentially. And if you Google for $100 a month, ghost volcano, you'll just run into my stuff. You'll run into my videos and nothing else. Nobody else says ghost volcano. And in this class, I haven't used the phrase ghost volcano until today, but I want to use it today intentionally, and it's part of the bold open. Here's the concept. Maybe you can stop taking notes for just a second, stop with the maps, and just, if we can connect with the bold open for less than 3 minutes, I'll be happy. We got a cone volcano in the Cascades. It lives and dies within a 2 million year lifespan. All cones have a 2 million year lifespan in the Cascades. So it lives, it dies, and it physically goes away. But there is evidence that those ghost volcanoes were standing at particular places, Zane. One way is to look at the magma chamber rock that was underneath the volcano. We're going to do a little bit of that today. That's my new twist on Old Scab Mountain and Cooper Pass. Plutonic igneous rock. You'll have to hear me out, but I'm setting the hook here with the bold open. Plutonic igneous rock that was not eroded away, but is revealed after that cone is gone. What else survives long after the cone dies and gets crumbled away? These tentacles, these worms, these arms of deposits that have been dumped into river valleys surrounding where that cone used to be. That's our frickin' class, man. That's a whole new way to sell the Upper Ellensburg Formation. We know that the Upper Ellensburg Formation, last time, is confined to the valleys. Follow the synclines. That was our last meeting. We're not just randomly going to places to find evidence of ghost volcanoes. We're going to valleys, we're looking at the sawdust in the valleys, and we're trying to figure out where those cones used to stand. I'm almost done with my bold open. I was yelling openly last Thursday, no surprise, in the field after the mirror incident. And one thing, of course, my old standby, what am I looking at? I don't understand what I'm looking at. Why are these soft pebbles surviving? Okay, that was old news. But the other thing I was screaming, and a couple of you were trying to console me, as the white trucks are zooming by us, is what am I supposed to visualize here or here, our two known sources? And a couple of you were like, well, didn't you say it was like a dome? I'm like, yeah, it was a dome, but I don't get it. Like, am I supposed to visualize a cone or not? Or a dome or not? Or a dome inside of a cone and the cone's gone, but the dome has remained? And as many times as I read all these papers and everything else, I still couldn't quite get it. I think I have it now. Our dacite plugs are shallow magmas. They're more plutonic igneous rocks than they are volcanic. And you're like, well, why are we calling them dacites? I think it's some... Nick, get settled. You good? Let's get our bag open. Let's get it all set up. Trying to set the hook here. Let's go. Yep. Dacites, in my mind, have always been this extrusive thing where we only get solid rock if we get it to come to the surface. But if you're willing to play with me today, the use of a term microdiorite, which never made any sense to me. Microdiorite, what the fuck is that? Diorite's a plutonic igneous rock. Diorite is a magma chamber rock. Microdiorite, that's literally what's been in pamphlets and even scientific papers for places surrounding Rimrock Lake. I think I'm onto something that I didn't have before. I don't know how to do it, but eventually today, or maybe it'll wait till Thursday, depending on what you want to talk about, we're going to get to this concept. The sources aren't going to change. Many of the narratives are not going to change. But visualizing specifically what Old Scab Mountain is and what we are dealing with, that's the deal. Who wants to react to the bold open? That was a few more sentences that I wanted. Jack, thank you.
So the dayside and the synclines, these are sources of shallow magmas?
Let's do some basics here first. So thank you, Jack. And we'll just keep going. So what are we staying with? It seems like I've given you a total curveball at the end of the quarter. I don't think I have. Most everything we've done, I want to keep. Are we talking about dacite being moved and dumped into these valleys? Yes. Are we going to have alternating river rocks and then these massive things? Yes. This is the sawdust, and I've got some new detail to help us tease out a couple of stories. But the dacites are all coming from the Cascades. The dacites are apparently distinctive. And your question, Jack, is, are we now saying that the dacite was emplaced at shallow levels as opposed to a plug of lava that was like, it's a part of the volcano that's remaining? Is that what you're asking?
Yeah, like the 31 plug.
The 31 plug. So even that phrase, the 31 I like, but the plugs, I don't know if I like the word plug because that implies a surface thing. Again, it was my hang up until recently. Go ahead.
What about like stump?
What about stump? Well, somewhere in these papers that I read for today, so now Jack wants to workshop with us and I love it. Ghost volcano. Let me try to draw quick. Okay, improv time. We got everybody here, I think. Let's do this. I think profile. It was in the Humphreys thesis, so we have a number of sources that were my responsibility. What have I used to get ready for today? I've used the paper that you've read, and we're going to come to you in just a bit, a rather short, 4-page, succinct paper that was everywhere in the department when I got here. This thing was flying around everywhere. So this was, 1992 when I showed up. So 4 years after this paper, everybody was talking about this paper. It's kind of gone the way of the dodo since then. But I'm using this. I'm using a couple other Gary Smith papers that I haven't had you look at, but they're on the website. I'm using a Sam Van Lanningham senior thesis from 1999, including all these samples from 1999 that we will talk about a little bit today. I'm also using I'm saving Carly Prater's senior thesis until next time. I'm using plenty of Chris Humphrey, which is also at the website, a master's thesis supervised by Paul Hammond in the Old Scap area and the Nile Basin in particular. So somewhere in all those sources, they started talking about 1 to 3 kilometers depth. The dacite, quote unquote, is emplaced below the ground at 1 to 3 kilometers depth. So there's a chance I'm obsessing about something that's insignificant. There's a chance that I'm just going to leave you in this last week of class with the wrong impression. Oh well, I'm going to give it a try anyway. If we're talking about studying these igneous rocks known as dacite, has compositionally dacite, and I'll give it to you. Let's play a game quick. I just need more input from you all. It's a porphyritic dacite. What does that mean? Big crystals and small crystals. It's a porphyritic hornblende biotite. What does that mean? It's got crystals of hornblende and biotite. We know that. All these dacites have that. These beautiful hornblendes. The black minerals are showing up all galore. A porphyritic hornblende biotite dacite. That sounds like a lava to me. And there are some dacite lavas at Old Scab Mountain. I'm not going to put it in quotation marks. There is a dacite lava flow that you can still go visit at this place called Old Scab Mountain today. That's the title of today's talk. I was going to do geography first, but I'm obviously on a little jag here. Just play along with me. And Jack got us going with this. I'm starting to wonder if that word dacite is just too casual. If it's just a compositional term, but it means lava. it means blocks of dacite in a lahar, and it means magma truly crystallizing under the volcano when the volcano was standing as much as 3 kilometers deep. Why are we still calling that a dacite? And that's where this term, I'm screwing up the outline there, what did I say? Microdiorite, I guess, is a more descriptive way to talk about the dacitic compositions that are a little bit coarser in texture, a little bit coarser in grain size, that do talk about this underground portion. Here's the reason I'm obsessing on it. And I'm not going to give you a great map, I guess. We know from last time we know this, right? Yakima's here, Ellensburg's here. We were screwing around in the Sela Basin, in the Natchez Basin, right? On Thursday. We didn't get to the Nile Basin. We won't. We're going here Thursday afternoon. But I'm obsessing about this because there is something called Rimrock Lake. This is an epiphany this morning at 5:30. So it's fresh, but I'm excited about it currently. Some of you know Rimrock Reservoir, Rimrock Lake. If it sounds familiar to you, you go to Yakima, then you hang a left, you stay on US 12, and you go to White Pass. You go to the Goat Rocks, and there's a big lake on your left. It's Rimrock Lake. There's a dam, so it's not a natural lake, it's an artificial lake. And there are some stunning, mountain is too strong, but stunning places to rock climb, stunning ridges, and they just pop out of nowhere. And I'll give you the names. Does anybody know the names of them? They're right there by the dam. Ryan, you want to try? You grew up in the area. Goose Egg Mountain is one of them. Kluchman Rock is another. West Falls Rock, you tunnel right through on US 12, right when you get to the dam. I'm talking about the eastern edge of the Rimrock Lake area. And when I went out, some of you are in the isotope class, I took a day in March with Hannah, and we scouted out where you guys would park and stop and collect as you did in early April. It was just her and I. We were talking about everything under the sun, including I say, hey, you know, I think you could do some work if you got interested. I think you could do some work on Kluchman Rock and West Falls Rock and Goose Egg Mountain. She's like, my God, these are amazing. So she stopped and banged a little bit, and we got a couple samples. She says, what is this stuff, and how old is it? And I'm like, I don't know. People keep saying it hasn't been dated well, and I don't even know what rock it is. What do you think it is? She's like, I don't know, like the texture's kind of weird. I said, they call it microdiorite. She's like, I've never heard that term before, ever. So there's a chance, young people, there's a chance that these landmarks that Ryan knows about are number 32, 33, and 34 of our sources for the Upper Ellensburg Formation. You're like, oh, come on. Certainly somebody would have figured that out by now. I don't think so. I don't think so. Some of these obvious known landmarks have not been studied carefully, age and chemistry-wise. And if you can tie some of the deposits at Thorpe with Goose Egg Mountain, that'd be pretty damn sexy. I'd make a video about that in a heartbeat, because these layers look gorgeous and that mountain looks gorgeous. And that's what I'm interested in when I make a video. I need some good-looking places that tell an interesting story. Maybe bonus points if it's a new story. I think it's waiting for somebody. And Hannah's here. Hopefully she'll get interested enough to do that. Okay, I'm way off my plan. But that is the idea that we're visualizing a cone volcano. Yes. We're visualizing Plinian eruptions. That's in the literature. That's in the paper today. Yes. Let's get to you now. What else was Gary Smith in the 1988 paper that you read for today? I mean, the first two words were eruption style in the paper. What was he talking about? I'll go anywhere you want to go. You've got some notes written down from your reading today. I know where I want to go ultimately, but I want to use your input here to go. What do we got? Raquel.
I found it interesting that he was talking about the eruptive behavior changing from the Sela compared to the Nile and Natchez basins.
Thank you. The sediments are not identical between these basins, especially it's very, very different in Nile versus Natchez and Sela. And so I definitely want to go there. Thank you. Yes, he made that point. Let's do some more just samplers here. Jack, on fire today.
He was saying there were modest-sized Permian eruptions.
Yes.
And then they were followed by dome growths.
Okay.
How does that link to the style of eruption?
I think he's trying to describe the style of the eruption that he can come up with in his mind from the deposits, especially that he finds in the Nile Basin. You guys have been in volcanology more recently than I am. What's a Plinian eruption? Indigo says that's a great question.
It's like the one that.
Oh, he's going to answer the great question.
It's like the one that happened.
They are going to answer the. Yeah.
Vesuvius in.
It's Vesuvius-like?
AD, but I don't remember any other information other than that's why it's called, because it's like the one that destroyed Pompeii.
I know what happened when Mount St. Helens erupted in 1980. Humble brag, I was alive. Was that a Plinian eruption? What's a Plinian eruption?
I was just gonna say, doesn't it contain pummices?
Pumices? Okay. You're like, well, you teach the class. Yeah, I don't know. He's talking about, nobody knows what a Plinian eruption is? How many people took volcanology with Hannah? Nobody?
No, we haven't had it yet.
Well, you haven't even had it yet. Not only have you not had it, you haven't even had it yet.
Hasn't been offered yet.
Hasn't even been offered yet. Furthermore, I think we'll get off of it. Nobody has it at the tip of their tongue. That's fine. He's describing two styles, Jack. He's describing these big mushroom clouds of ash. That's all I know. And then he's also talking about portions of the cone, hard to draw, portions of the cone getting removed, whether it's a big landslide converting into a debris flow or something else. And then inside of the cone, again, think Mount St. Helens, there's a dome inside of the crater. And we have spasmodic growth of the dome, then the dome collapses and flows away and out of the crater. So Jack's kind of obsessed like I have been lately. I want to know, what do I want to visualize for Old Scab Mountain? I can just draw that, but is that really, what am I even drawing here? And is a cone much bigger than that? Can we take 3 or 4 of our cherished plugs and realize that they're part of one ghost volcano? I don't know the answer. But I'm about to share with you something on the other side of the board that shows you we are miles away from anything conclusive. And so it's always dangerous in a class like this where you're reading papers and you go, they didn't really speak to me. I didn't really understand what they were talking about. Well, these papers are all baby steps in understanding. Rarely do you find a paper that gives you a very clear picture and like a finished product, even with somebody who's working in the area for a long time. Sometimes you need to wait for a review paper to get all these prior papers together to have some sort of coherent message. So I'm just trying to get us up to speed on what we know and what we don't know about the deposits as well as the source. Okay, I want to, believe it or not, I want to come back to you again. I just want to get a few more voices in the room, and then I'm going to go with my plan that I think I have now. Somebody besides Raquel and a few others that have spoken before. We got a lot of dead wood in the room right now. Let's wake it up. Let's go. What else we got? Raquel.
That the deposits were reworked and transported, remobilized by moving water and ships.
We are going there, I guess, now. It seems like Raquel and Jack are kind of getting us in this, they're goosing us in this direction. The other thing I was screaming about on Thursday is a long time rant. I don't understand how some fragile pumice clasts can travel 30 miles down a river. And it's a new concept to me that some of that most fragile stuff has been reworked locally. It's almost like Barbara's Cougar Point Tuff. Why did we have 30 feet of Cougar Point Tuff? The concept, I'll ask you, why did we have 30 feet of Cougar Point Tuff at Mattawa where we didn't have it 30 feet elsewhere? Austin.
In that area, like it's all over the place, but then the river just brought it into.
So we had initially We don't know, but we had initially a few inches of Cougar Point tuff everywhere. And then since the eruption, there was enough topography to have local streams and rivers and gravity-fed whatevers to rework, mobilize that stuff locally and get it into a depositional basin. I think I'm feeling better about the pumice, these soft pebbles, to know that they really didn't come out of the air and land 30 miles away from Old Scab Mountain, nor did they get carried by a river 30 miles down. Julie sent me a couple of detailed papers over the weekend about soft pumice class. I think they're local pumices that have been washed into the basins from nearby. And I think that reworking is a story. I don't think it's the main story, but I think it's a secondary story that helps me understand some basics. But now I realize I gotta get along with my plan. Gold star to a few of you today. Thank you. Okay, let's establish at the halfway mark, believe it or not, what's going on. Ellensburg to Yakima Umtanum Fence. We know this. Umtanum Fence separates Cooper Pass, which is a known source, from Old Scab Mountain, which is a known source. The lay of the land is northwest-southeast. The ridges are northwest-southeast. The valleys, aka synclines, are northwest-southeast. Northwest-southeast is the dominant story. I hope to finish today with a wild card, with a rogue tentacle, with an arm from a ghost volcano that's going against the grain and saying, fuck this northwest-southeast grain, I'm going my own way. And I want to look at the evidence for it, coming from Sam Van Lanningham in 1999. Are you okay?
Yes.
Julie?
So, tentacle, is that erosion?
Tentacle is just my pet name for an octopus. What's a tentacle?
But is it?
It's if we're looking.
Tentacle, but is it erosion going
On, you want the punchline now? I'm going to build to the punchline, Julie.
Sorry.
But the concept on a map, I'm dashing the outline of our volcano that lived and died and had a 2 million year lifespan. And here's our tentacles that have outlived the cone that made them. And what's in the tentacles? Mud flows, blah, 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 all the stuff we're going to talk about in just a second. Okay. We got a tentacle that's not... So far, we've talked about tentacles that are all marching parallel to each other. They're filling troughs that are in a northwest-southeast trend. I'm not going to tell you about the rogue tentacle quite yet. Okay. Splidam, 2 choices. I understand it's the end of the quarter, but some of you are just, you got nothing for us here. It's clear you didn't even read the paper. It's a 300 level class. I expect a little bit out of you. Okay. Last time, I could have been a little more clear, and that became clear to me when we were in the field. And by the way, when I say we were in the field, there's less than half of you that come on these field trips. Oh well, but I'm just saying that everybody was there. We were in some fluvial sandstones, and everyone that I was sitting with were like, especially at Natchez, were like, oh wow, so this is what a mud flow looks like, and this is a splidam. And I realized I didn't communicate some basics. So let's do the basics. I think generally, if we're above the kitchen table, anywhere in the upper Ellensburg, above the kitchen table, which is 11.81, running till about 6 million years ago, which we're doing again this week, there's alternating quiet river deposits and splidam. And the splidam was my pet phrase for a belch of material dumping into the valley quickly. And there was no time for layers. We said this on Thursday, but I guess it didn't resonate. So what I want to add to my sketch, which maybe I should have had last week, and I'm drawing layers now kind of that don't fit the circles that I drew, but these are river cobbles, and all I want to simply show is that our quiet river chapters do not have volcanic explosions at the source, and it truly is just another day of rolling these cobbles, and in many cases sand. A surprise to me is that there was a lot of sand in some of what we saw on Thursday afternoon. Sand which was dacitic, so the composition of the sand is also coming from our source, the old Scab Mountain, but it's sand with not big cobbles. So what we're really leading towards is this massive thing, which, in the field we were saying it's splodam, and then I started to get depressed. Like, am I teaching anything here? We're just using the word splodam. That's so stupid. So I want to be more true to the sedimentology, believe it or not, today. And I did really enjoy getting some clarification from the sources that I mentioned earlier. We have the first pass through it, which was hopefully reviewed from last time. Splodam means lots of dacite, maybe 100% dacite, all coming in at once. But there's some nuance that I think is important, and I personally am excited to go out to Thorpe on Thursday afternoon to look for two choices when we see a massive non-layered portion of the Ellensburg Formation. DFD HCF. Debris flow dump, hyper-concentrated flood flow. Yes, I'm the instructor. Yes, as recently as a week ago, it's like, I don't care about hyper-concentrated whatever. I care now. It makes sense to me. And it's this cross-section that made it work for me. So let me take my time now, see if this works for you. I feel, who knows? It's a silent room, but I think maybe I'm communicating with just some of you. So let me say it one more time. I'm now going to go into this orange and pull out two different potential stories in the massive stuff. I used orange for a reason here. Okay? Words that are all through these papers, so I want to use them for the first time. Proximal, medial, distal. Basically, how close to the volcano are you? Are you right next door? That's proximal. Are you far, far away? That's distal. I think many of you know those set of terms for other reasons. But the numbers helped. To me, if you are within 20 miles of Old Scab Mountain, you should be expecting proximal sedimentology. The deposits should look proximal. And you're like, I don't know what that looks like. Well, that's where we're headed. So a rough number is 20 miles from the source. Things are proximal. And the proximal look of the deposit is a debris flow. If you get carefully into these papers, not everybody loves the term lahar. Lahar is too casual. Volcanic mud flow is too casual for their taste. So if you really read these papers, which you were not expected to do, lahar is almost slang, or they're saying laharik just to cover their ass. So let's go ahead. Let's play with the story. A dump of debris flow material separate from hyper-concentrated flood flow. I don't expect you to be excited yet. I wasn't either until I got a little further along. But here's a major point. Finger goes up for some reason. Not an offensive finger either, just a regular index finger. If we go to an outcrop on Thursday and I think, what do you think? You think this is DFD or HCF? You're like, yeah, I guess it's HCF because of the criteria you told me. The breakthrough for me is that the debris flow converts into a hyper-concentrated flood feature. Too many syllables to say quickly. And I don't have the acronyms in my head yet, so it's cumbersome. Okay, all right. HCF, DFT. The long version, hyperconcentrated flood flow, hyperconcentrated flood flow, hyperconcentrated flood flow. You happy, Julie?
I am, thank you.
You're welcome.
Free entertainment, man.
So I didn't care about these two distinctions because I assumed that if you call the thing a hyperconcentrated flood flow, that's something weird happening at the source versus a debris flow, which is something different happening at the source. It's just a question of how far from the source are you and how do you eventually convert from a debris flow into a hyperconcentrated flood flow. I have notes. I'm still building to something. I'm going to give it to you verbally. Are you awake? What's the difference between these two? I'm not asking you because you didn't read these papers. What's the difference between debris flow and hyper? I'll just abbreviate it that way. Debris flow and hyper. You with me? We know so far that the hyper is further away from the source. But we want to actually go out and see these deposits and make a call for ourselves. This is debris flow or this is hyper. Here's a couple. The debris flow has more than 80% rock versus water. So we know that these flows of stuff coming away from a once dominant cone has a mixture of rock and water. But now we're down to actually caring about how much water is in the thing flowing down the valley. Debris flow, less than 20% water, aka more than 80% rock. Versus the hyper stuff, which is 50-50. 50% water, 50% rock. A true balanced slurry of stuff. So of course it's going to be more fluid if we're up to 50% water versus 50% rock. I'm building to something. We're still within the splodam and deciding by making a call, 1 versus 2, ultimately how close are we to the source? We're hunting for the source. And if I got a bunch of proximal debris flows in an area that somebody took the blindfold off, I must be within 20 miles of the cone. That's pretty valuable. I'll give you 2 more differences between these two, and then we'll open it up to see if anybody else wants to speak. Debris flows are matrix supported. So you know that we have, in a mud flow, let's say, we have big rocks, those are clasts, and then we have a bunch of kind of smaller grained stuff surrounding, and that's a matrix. I know those terms are used in igneous geology and metamorphic geology as well. I think we all know what a matrix is. It's background, right? So with the debris flows, we are matrix supported, meaning if we have a bunch of big boulders in our debris flow, they're not touching. The matrix or the fine-grained stuff is having those things float in suspension, indicating there's a lot of drum and things are coming in very quickly. There's no time to settle at all. We don't have time for layers, but we don't have time even to settle at all. Compared to a hyperconcentrated flow, we are clast supported. We're more fluid now, so a couple of our bowling balls, the clasts, are going to be touching. They're going to be supporting each other. This should make sense to you, that we have less fine-grained stuff. The fine-grained stuff is probably being flushed further downstream, and what we're left with is clast-on-clast crime. One more wild card between these two types of deposits. I love contacts. I love boundaries between very different kinds of deposits. As a video person, I love putting my finger on something and then looking into the camera and saying, you know, something happened dramatically right here, like a big tsunami came in at the coast and like there's the very dramatic boundaries. Look how different it is on both sides. Apparently at the base of these debris flow dumps, there's no grading. There's no organization of the sizes at all. it's chaotic right down to the true base. Again, indicating that there's not a bunch of precursors and water kind of slowly coming into the area before we have a big event. It's just a big dump. It's just a big spladam, in the truest sense of the word, coming into this peaceful place. I guess that implies there's a little bit of grading at the base of a hyperconcentrated flow. That's probably enough in the weeds, but indicating that we have really two different choices in this orange spladam zone ultimately helps us know that we're close by. Here's what I'm leading to, and then we'll open it back up to you. We'll see if you want to talk. The Nile Basin is proximal. I'm going to ask you, actually. So based on what I just told you, what would you expect to find in the upper Ellensburg, in the Nile, versus the Natchez? This one sounds like a good question for next Tuesday. Gavin.
Well, by how you described it, at Nile, we should be finding debris flow with the class in a matrix.
We should have mostly debris flow dumps in the Nile Basin with clasts supported by matrix. Is that what you just said, Gavin? Yes. I'm going to spitball off of that. There are massive lahars. So there are true lahars in the Nile. And those true lahars are up to 100 feet thick. Individual lahars, 100 feet thick. Like, what is that? Almost the height of whatever. Those are massive, thick lahars. A vote for proximal. I'll just follow the logic. We're going to get less proximal. We're going to have less debris flow dumps in the Natchez or the Sela. You're like, bullshit, we saw some pretty cool stuff at Sela. We hiked up that road. We saw some beautiful spladams. You're right, we did. They weren't 100 feet thick. And now that I realize the difference between hyper and debris flows, there was plenty more hyper in those outcrops we saw last time. Do I need to write it for you? These are dominated by medial deposits, and the Nile is dominated by proximal deposits. I think you have it by now. Something we haven't talked much about yet, but is a major part of this, are crossbeds. I think we all know, even from 101, what a crossbed is. If you have flow and you have grains of sand, let's say, and we're carrying those grains of sand downstream, we're going to deposit some sand layers on a slope. And you can carefully measure the orientation of those crossbeds in 3 dimensions to do what? To figure out what direction the flow was happening. Whether that's the debris flow itself, or more accurately, what's happening in the hyperconcentrated stuff. With all that water, what direction is the water running? I'm timing this just right. I think I am. All the crossbeds in the Nile, Natchez, and Sela have a northwest to southeast crossbed signature. Even the sedimentary structures in these basins talk about the source being to the northwest. Northwest to southeast. So proximal being on this side of the medial makes sense. Crossbeds also saying the source is coming from up here. Is everything coming from specifically Old Scab Mountain? That's what I'm building towards. The answer is no. But we're getting up into this general nature with these major chutes coming out of the Cascades. Is your hand up, Scene?
Uncertainly so.
I can do that too.
Yeah, so
I can do this.
I don't know if I'm jumping ahead, but Thorpe is hyper.
You are kind of jumping ahead, but let's do a little bit of it now. I think if we have to pick one label, we pick medial and not proximal for Thorpe.
Thorpe is medial.
If we have to, but that's Thursday really. I haven't carefully looked yet. But I think Nile stands out as a super proximal story. Let me give it to you verbally. Nile, which I'm just trying to indicate to you, is a different animal from these other sawdust piles because it's right next door. It's within 20 miles of Old Scab. Nile has 25% pyroclastic flows. There you go. We haven't even talked about pyroclastic flows yet. White hot traveling clouds of hot rock and ash and debris killing everything in their path. 25% of the pile in the Nile is just those pyroclastic flows. The source has to be close by. Daddy's excited. 20% of the pile in Nile is massive lahars up to 100 feet thick. 30% is conglomerate. 20% is scoured sandstones, dacitic in composition, which leads, 5% candy bars or something in the Nile Basin. So Thorpe is Thursday, and we will see some differences with Thorpe. But before we get too excited, I want to put some water, no pun intended, on our excitement, which I think is real from a few of you. I spent the time this morning. Our cat got us up at 4, so I've had extra time to work on this. And I took every date I could find. And the handout you have is something I found in an email from a friend of mine, Andy Miner. And I don't expect you to memorize the sheet, obviously. But I took the time to grab many of those known dates in the last 30 years, took the time to look up the locations of the samples, and hoped to find something that was just a nice, coherent story. And the main message is, there's not. I'm slowing down in the last 5 minutes just to make sure we have this, and we'll build off of this. We haven't gotten to the rogue tentacle, Julie. Should I leave? Are you going to sleep well if I don't tell you the answer in the next? You won't sleep well. Okay, we'll do okay, good. All right, any more down? Yeah, there's another piece of downtown to put that in. Good. Bumping Lake, we know that's our focus point today. Old Scab is up there. But there's, I don't know, you pick a number. According to the handout I just gave you from Andy Miner, there's another dozen sources just in the Bumping Lake area. So I'm not labeling this Old Scab Mountain necessarily. I really don't think you need to write down every number here, honestly. Thank you for being careful students. The main point is, here's our tandem fence. The narrative from everybody, including Gary Smith, is that we have the source at Cooper Pass, which I have to say, can you look at your other outline quick? I'm going to run out of time. Daddy's going to run out of time. Can you see the stippled pattern? I just noticed this an hour ago before we started. This is from the paper that you read, quote unquote. And the dotted, the stippled, is the upper Ellensburg, the sawdust. And I took a little pen and I started coloring for myself all the little dots. What's at Cooper Pass? Cooper Pass isn't even a dacite bedrock thing. The dacite bedrock, the sources are these block things. So why the hell are we even talking about Cooper Pass as a source if there's a bunch of frickin' medial sawdust at Cooper Pass? So I got 48 hours to figure that out. Or at least read what I can. But that was a shock to me. My point is, Stone Quarry, that's the surprise ending, Thorpe, Nile, Natchez, Sela, have some dates that have been found in the last 40 years from what? Distal, proximal, medial, stuff falling out of the sky, pyroclastic flows, whatever. But you know by now, each of these things circled in yellow are depositional basins. Wouldn't it be nice if we had a bunch of dates from the Natchez sawdust where all the trucks are zooming by, and all those dates matched with one specific spot in the Cascades? That's what we're going for. Look at the age range of the quote-unquote dacite or microdiorite source rocks, bedrock in the Cascades. There's no agreement whatsoever. On the upside, there is some petrologic and stratigraphic connection. So this isn't truly a bunch of darts on the dartboard. I wouldn't waste your time if this was just a total crapshoot. The people who have done the work do see a connection with the Cascades. And they do see a connection from crossbeds and other things to the northwest. But the devil's in the details, actually finding specific sources with these ghost volcanoes and these deposits. And you're like, I officially don't care. Fuck this whole thing. I don't care about this at all. Are we done? It's June. It's hot. I want to just go lay out in the sun. Think about nothing. I understand what you're saying. But this is a local set of deposits that I think we are close to actually figuring this out. It just takes a few more rounds of senior theses. Hannah Shamloo, are you listening? Jordan Carey, are you listening? I think in the next 10 years there could be major advancement on this. And we don't have to keep using samples that were collected by my buddy Sam Van Lanningham in the late 1990s to figure it out. Okay, Julie. 1 minute. It's about time, she says. I need to power up. Sam went to one of the little stippled areas at the base of Menashtash Ridge, a little quarry called Stone Quarry. I drove out there the other day. It's a bunch of private land. I remember visiting Sam out there, and he showed me a few things, but I don't think it's worth going to. You could talk me out of it if you like this. We're north of the Umtanum fence. Sam looked carefully at the medial, the distal. He had a pyroclastic flow, like proximal. And he says, I have all sorts of data, including crossbeds, motherfuckers, including crossbeds, to say that some upper Ellensburg at the base of Menashtash Ridge is flowing southwest to northeast. And you're like, well, that's cute. He was a senior. He had no idea what he was doing. He had the whole department involved in that project. He was a charismatic guy. He had the entire collection of our professors working with him, doing thin sections, doing point clasts, cobble clasts. He was collecting. He was making thin sections. He was doing chemical. He was meeting with Paul Hammond. He has a convincing case. It's on the website. We scanned it. Andrew Sadowski scanned it last week. That this is the rogue tentacle. And you're like, how is that even possible? And the answer is the Umtanum fence has to be low. This is a 10, these are Sam's dates, 10.3 and 10.2. So Sam says, look, man, I know Gary Smith says everything has to come down the chute from the northwest, but I have crossbeds coming from the southwest. I've got chemistry matching. I've got some dates that are pretty freaking similar to some of that stuff up by Old Scab. I've got an old river valley before Umtanum fence got nice and high. And I admitted to you that I made a video talking about that story, and I'd forgotten when I was talking to you earlier this quarter, it was Sam's work that got me going in that direction. And I found some old emails from some other experts that said, yeah, this is a very intriguing senior thesis, which nobody's thought about for 30 years. That's the wrinkle at the end. And if that's true, is it possible some of the Thorpe stuff is from Old Scab? Is it possible this whatever source is sending stuff down this way? We're going with the most obvious narrative, but is it that simple? Maybe there's some stories there that are totally unknown. Thank you, young people, for your attention today. Do some drugs between now and Thursday. Would love to have more personality from you on Thursday afternoon. These are drugs. Vinman's Bakery has created beautiful things for you. Please enjoy. Take a bunch of extras on your way out. Anybody want to talk to the home crowd today that hasn't done it before? Thanks for joining, everybody. I hope you enjoyed today's episode.
Nick, you said you like erosional contacts. I found something you might like on our trip. We were digging holes. This one. We have a storm deposit right
Oh,
there.
wow, Ryan.
Yeah.
You got 5 minutes?
Sure. Yeah.
Let's come talk to these guys. Have you talked to these guys yet today? Okay.
Yeah.
So,
Earlier.
So Ryan talked to you earlier. Ryan's from SELA, and he was just on a geomorphology field trip with Dr. Bree McGinnis. And I thought it'd be fun for those guys to hear a little bit about what you guys did this weekend.
Yeah.
And if you want to address any questions, you can. But just, I think that photo that was tsunami. That was
Not tsunami, but storm. So I'm hoping maybe it'll show up kind of well on the camera.
Kinda.
You can kind of see it. You can see that. So right there, kind of at the base of right about there, you can kind of see it's an erosional storm scarp that we found. We went on a coastal geomorphology trip, so we went to the beach. It was really fun. But we left last Thursday, so that's why there's a few of us not in class. And we got down there. We went to Westport, pretty much all down. We went down to Peter Iredale, all that stuff. And we all had projects. And my project was to dig a pit and look at the sediment strat. Yeah, sediment strat. And so we saw some cool stuff. There was a lot of footprints. Depending on the magnetite level, you can kind of see it. The magnetite is what really made this stratigraphy pop out well. But yeah, there was storm scarps. We saw 2 or 3 of those. I was in a group with James. James is here because we had to drop him off at the airport on our way back from the beach. He's down in Albuquerque right now. And then Maggie Egan, a master's student, was also a part of my group. And yeah, we saw some cool stuff. We were digging below high tide line, above high tide line. We saw some dunes forming, some wind dunes, some water ripples. It was pretty cool. That trip was a lot of fun. We camped for 3 nights. It was a Thursday through Sunday deal. It was a long drive back. I pretty much sprained my ankle walking out of the van on the last day, of course. So it was a time. But yeah, the Peter Iredale was awesome. Like, that was definitely one of the best beaches we went to. It was amazing. The ship was cool. Sage isn't here, but Sage was also on that trip, and we all ran out and touched the ship. We were right at the shipwreck. We saw some cool stuff. Maybe I can pull my phone out again, and maybe it'll show up well. But at the Peter Iredale, since it's kind of like right at the mouth of the Columbia, there's a lot of magnetite. So here, we'll see if I can get this to show. Oh, that's pretty good, actually. So yeah, we got these. Those little ripple marks are actually footprints from people running on the beach in the wet sand. And then the big, thick black beds, those are magnetite beds from storms. We don't necessarily see storm deposits there. We didn't get deep, my pit was not deep enough. James's, on the other hand, which I don't have pictures of, there was a very large storm deposit below that, coarser grain, nice erosional contact. It was really cool. I kind of want to go back to the beach. It was awesome. Yeah, it was just like so the storm scarps that I'm talking about for David, they're yeah, just horizons ending by storms, like very clear erosional contacts, usually depicted by a coarser or denser grain above the scarp from the storm deposition. Yeah, we had beautiful weather on the trip. Actually, it was awesome. Other than I think it was Saturday. Saturday was raining in the morning, and so we stayed at Cape Disappointment State Park, and so we got up and went straight to Bench and Beats. Walked straight from our tents, pretty much. Ate some breakfast, walked straight out there, and it was raining, and we were all soaked to the bone, and it was real cold. But then so we went to 6 beaches that day, and after about the second one, it cleared up. Got to walk in a mud flat too. Never done that before on that. Yeah, definitely. The trick was definitely interpreting that. It was a new skill that I was learning. So Bree, she came up to me after about the second beach and was like, "You need to work on your cleaning of faces." And so she taught me how to properly clean a face of a pit, which I had never done. I never dug a pit like that, a stratigraphy pit, and she taught me how to do it. She was taught by the great Brian Atwater, so she taught me to start cleaning and never stop. So I pretty much never stopped cleaning until I filled back in that pit. It was really fun. Yeah, it was it was a time though. The beaches were awesome. There were a few beaches where we couldn't see much, so I was typically digging a pit 5 meters above the high tide line to see. Our hypothesis was that there would be, it's pretty simple, but more aeolian or wind processes the farther above high tide you get, and then more water closer to high tide and below high tide, which is pretty much what we've seen. We saw a lot of swash, which is low angle, like crossbedding. We saw a lot of that in our pits. Scene back here, actually, he was also digging pits, but he was looking for the human impact. So like those footprints I showed, he was looking for those. Tire tracks, we saw a lot of those. Those were really cool. It was really fun. We actually dug some pits together, filled in our pits together. And so he was working with Cassidy Deere, another master's student, and their project was digging pits, looking at sediment stratigraphy, and to see human impact, so tire tracks, footprints, that kind of deal. And it was really cool. Like, I never expected to be able to see footprints in the beach face. Like, I figured the waves would rework it all, but nope, it's clear as day in some of them. It is definitely clear as day. I would definitely I would definitely recommend Disappointment. That place was beautiful. Cool. It was so beautiful, and it was an awesome state park. We went to Waikiki Beach too, which is actually on the Columbia, and it is just straight up magnetite. There is not. I mean, it was a really cool beach. It's smaller, since it's kind of just like an alcove in the Columbia, but it is all magnetite sand, so all that really dark sand. And that was a fun day. Going to Waikiki. There's a bunch of, that was the one where we actually had like a bunch of other people at. Peter Iredale was the other one, but most of the beaches when we went to them, there were like a few people around, but sparsely. But Waikiki, since it's a smaller beach in this little like alcove, there's a lot of people there, and I think Scene actually dug. These people were sitting there, and Scene dug like 10 feet from him, dug a trench to look at for his his footprints. It It was cool. Yeah, that is how Aeolian is spelled. Some people drop the A, I've seen. I wanted, so actually, Daniel, the scuba gear, I wanted to look at longshore transport originally and the longshore current. So I probed Bree about this a little bit about getting into a boat and rowing out there and taking some longshore current measurements. She was not a fan, rightfully so. That would have been really dangerous. We're not able to date the footprints necessarily, because the rate of deposition on those beaches isn't like a constant factor, so it's kind of hard. At least we were kind of able to date the storm, because we know the last big storm was the 26th of December over there. So that's what we're assuming those big scarps that we were able to see were from that December 26th storm. And plus, we're in the spring and getting into the summer now, so the beach face is actually starting to grow, because when it's stormier offshore in the winter, it kind of shrinks back.
Wow, thank you.
Yeah.
You're really going for it.
Yeah.
You want to keep going?
I can go a little longer.
Okay.
I got one question here. It says, where does the magnetite come from? So the magnetite actually comes from the Columbia. It's a heavier, excuse me, sorry. It's a heavier, more dense mineral that's formed in a lot of different rocks. And so, especially in subduction zones like we have, so they're forming, and then as it's all eroding away and coming down to the coast, it's concentrating these magnetite beds, and it's all kind of spilling out of the Columbia. So the fun thing that we saw was the closer we got to the Columbia, the more magnetite we saw. So at Peter Iredale, Waikiki Beach was all because it's on the Columbia, but Peter Iredale had a ton of magnetite. Benson had quite a bit because it's kind of right there. There was one beach closer that I'm forgetting the name of, but that had a lot of magnetite. But we also went up the Long Beach Peninsula all the way to Oysterville on the other side. And those beaches were, so to see sediment stratigraphy, you need a difference in grain size or color. So it's with a lot of magnetite, it's really easy to see changes in sediment stratigraphy because it's darker than most of the other grains, such as like the quartz and plagiarid clays and even some olivine. But yeah, so as we got farther from the mouth of the Columbia, there's less magnetite, and it was much, much harder to see these stratigraphy faces, like if there was anything there. Yeah, David, that's the longshore transport. I really wanted to look at that current. I think that current's so cool. I've been interested in it in a while, but yeah. All right.
That's plenty.
I think I'm done. Yeah.
Thank you. Thank you for helping out.
No problem. I'm happy to.
I'm sure they loved hearing about your trip.
It was a fun time. Thank you.
Thank you, Ryan.
Yep. See you on Thursday.
Bye-bye. Okay, I've got a few minutes to visit with you all if you're still here and want to ask anything about today's lecture, or I don't know, the rest of the class, there's only one more lecture. I think I know what I need to do before Thursday, and that is to do whatever I can to read up on what's out at Thorpe. And Thorpe is a little farming community less than 15 minutes away from this campus. And yet I've always been frustrated by those deposits. So I think there's a chance I'll find a couple of narratives that these guys have gotten me going on. Raquel is really doing well lately. So she always asks a number of questions afterwards to really make sure it go, oh, she's hearing her. I'm talking about her.
I'm just kidding.
Sorry, Raquel. I didn't know you were still here. I didn't mean to embarrass you. Okay. Chris, have you talked to these guys? Do you want to talk to these guys?
I don't think I've talked to them.
Come on, Chris. This is Chris, who's also in the class, obviously, and Chris has not talked to you yet. Why don't you just tell them, where are you from? Anything, how long have you been in the program? Why are you with us? That sort of thing.
Well, originally I'm from Nevada. I moved to Washington 6 years ago. Got involved in geology through my community college in Longview, through my volcanology professor. And that kind of sent me down the rabbit hole of geology. And then I got invited to do a spring trip with Central with mineralogy professor Chris Mattinson, and that kind of suckered me into continuing geology and coming here. So I've been here a full year now, just about.
What did you expect before you arrived, and what were you experiencing when you first got here?
I guess I kind of expected more in-depth geology, which I definitely got. I mean, my first class here was rocks and minerals, which was definitely a challenging class, but a fun one. And I guess coming here, I was done with all my like 101 stuff and general education, so I think I was kind of really hungry to get more into geology classes again, because when you're not in the classes, it's hard to remember and retain some of the information because there's just so much to remember, especially going on to harder classes.
Right. And what was the name of your community college instructor in geology?
My instructor was Dr. Morgan Salisbury. He's a volcanologist. He's currently in South America right now, teaching at one of the universities in Bolivia. In fact, he just went out for field observations with his students. They just got stranded somewhere.
Oh,
in some
really?
village. Yeah, their car broke down, so they had to do a pit stop before they went to get samples. So.
Wow, so you're really in touch with him.
Yeah,
huh?
I talk to Morgan quite frequently.
Nice.
It's always good to touch base, and it's good to hear what's going on geologically in other parts of the world that are being studied. And I think it's kind of a privilege to know
Yes.
someone in that area that can say, "Hey, look what I'm doing," and it's really kind of a cool thing. So,
Nice.
Yeah.
Okay. Well,
thank
thank you,
you.
Chris. I appreciate you doing that.
Yeah, you're welcome.
Okay. Yeah, Morgan Salisbury is a former student here at CW Geology, and in fact, many, maybe most of the geology instructors who are now at two-year colleges are graduates of our program. So essentially, we have a network now that we have. It wasn't intentional, I don't think, but it turns out that network of our former people are now doing the heavy lifting at all corners of the state. So we still have more than 300 if you want to spend a couple more minutes. I think on Thursday, our last class, I'm going to be itching to get out of here and do our final field trip. And yeah, it was risky. I don't know if you've been with us a long time, but when I did the 101 live streams 4 or 5 years ago, there were gifts that people were sending in to the students, which officially is a no-no, but whatever. And somebody sent in a box of cigars. And I knew we had some students over 21, but most were under 21. So I just said, hey, here's a box of cigars from Larry in Albuquerque, New Mexico. So if you're of age, you grab a cigar on the way out. Well, that didn't go very well. So I got in trouble for that. So will I get in trouble to get a bunch of students in my backyard and drink some wine, which are some gifts from many of you? At this point, I don't care. I don't care if I get in trouble. Okay, I'll look for some uppercase with some questions from you, and then we will say goodbye today. I don't have enough hands to scroll back. Will I share questions from the final like I did on the midterm? Probably not, Terry. I'm not going to be in town next week, so Sabrina, the grad student, will be proctoring the exam. Oh, Raquel, I'm sorry. You wanted to talk to me. Let me wrap things up here. Stevie Pinhead's talking what a groin is. Thank you, Stevie. David, I like the concept of the pop-up geology thing, but I'm just not actively thinking about it. So my public appearances these days are either in downtown Ellensburg every April, or occasionally I'll speak, like I did on Sunday on Natchez Heights with a guy who owns a vineyard and wanted me to come. And to my surprise, he charged admission, which I didn't expect. But I have a few little things like that. But otherwise, I'm not doing a whole lot of public stuff these days. Maybe I'll get back into it, but for now, I don't think I'm feeling it. One of the bottles of wines that we will drink is a Brett's pictures on the bottle. I forget this. I've had it for a while. I forget who gave it to me, but thank you. Raquel wants to chat a little bit, so I think I'll say goodbye to you all. Thank you for tuning in. Let me give you a shout out the window quick before we say goodbye, and I really do appreciate y'all watching these classroom sessions. It's a new thing to try to live stream from my classroom, and if the administration knew that I was doing this, they would not be happy. But I personally think it's an effective way to communicate that real teaching and real students are still happening here, at least a little bit. Thanks, everybody. You need your shot out the window. There's an administrator right now. And administrators run thick around here.